What's up, everybody? It's Miles here from bootcamp.com, and today in pulmonology, we're going to be going over surfactant. So, surfactant is a substance produced in the lungs. It is derived from multiple molecules called lecithins, and the main lecithin that you should keep in mind is one called dipalmitoyl phosphatidylcholine. And surfactant is produced by cells in the alveoli. Specifically, it is the type 2 pneumocytes, and this is a super high yield fact to remember. And can you remember the second really high yield thing we said about type 2 pneumocytes? That's right, they're involved in regeneration of lung tissue after lung injury. So type 2 pneumocytes are very high yield cells to keep in mind. They're involved with regeneration and production of surfactant. So let's just recall that our alveoli was mainly composed of these long, thin, slender cells called type 1 pneumocytes. And kind of located in the corners of these alveoli, we have these large cuboidal cells, and those were our type 2 pneumocytes. And so the type 2 pneumocytes are going to be producing surfactant, which is then going to coat the alveoli. And within the type 2 pneumocytes, the surfactant is stored within an organelle called a lamellar body. So if we were to blow up a type 2 pneumocyte and we were to analyze it under an electron microscope, we would see an organelle that kind of has all these flat membranes that are layered into lamellae. And this is called a lamellar body, and it stores surfactant within the type 2 pneumocytes. So before we actually go over what the purpose of surfactant is, we need to backtrack a little bit and talk about some basics. So let's recall that we had our lungs, and the lungs always have that tendency to collapse. But what properties do the lungs have that make it want to always collapse? Well, we said, first of all, that the lungs have a lot of elastic tissue, specifically two substances. Elastin is one of them, and collagen is the other. And so elastin and collagen make up the elastic tissue, and that's going to be one of the collapsing forces. The second collapsing force is something called surface tension. Surface tension. And the way that I think about surface tension is, let's just draw in a cup of water. So the water molecules that are located at the surface of the cup of water, we call that the air-water interface. And the water molecules that are located within the cup of water, we call those molecules part of the bulk. So the water molecules that are part of the bulk or within the cup of water, they are going to be completely surrounded by other molecules of water. And so they are going to have every single one of their hydrogen bonds is going to be touching another molecule of water. Whereas the water molecules on the surface up here, well, they can make hydrogen bonds to molecules beside them and below them, but then they have this bond left over on the top. And since water molecules don't really form bonds with air, and so as a result, they use that leftover bonding to form these very tight bonds with the water molecules adjacent to them on the surface. And so the water molecules on the surface are more tightly bound to each other. And as a result of this very tight bonding, this surface layer of water molecules here actually binds so tight that the layer contracts. It contracts, and there's going to be tension on the surface, and that is called surface tension. And so if we bring this back to the lungs, we go back to our alveolar drawing here, there is a small layer of water that actually coats the alveolar surface. And the surface water molecules in the alveoli also exhibit this surface tension, and so that surface layer of water molecules is going to cause the surface layer to contract within the alveoli as well. And so we can imagine we have our alveoli and it's coated with a layer of water, and on the surface of that layer of water there is water molecules that are very tightly bonding to each other and creating surface tension. That surface tension is contracting the surface layer of water, and that contraction is also contracting and collapsing the alveoli. And so surface tension is actually a collapsing force that is trying to collapse the alveoli and bring them to a smaller volume. And now we can bring surfactant into the picture. So like we said, surfactant is secreted by type 2 pneumocytes that's secreted into the alveoli, and it's going to coat the surface layer of water that exists within the alveoli. So going back to our cup of water here, the surfactant would be coating the surface of the water. And because surfactant is a phospholipid, it has a hydrophilic portion, which is going to bind to other water molecules. And as a result, those surface water molecules can bind to surfactant, and so they won't have that leftover excess binding energy, and so they won't bind to each other as tightly. And surfactant also has its hydrophobic portion, which does not undergo hydrogen bonding, and so the surface layer of surfactant actually doesn't have much surface tension. It doesn't contract like a surface layer of water molecules would. And if we go back to our diagram of the alveoli, we'll just put our surfactant molecules in here. And as a result of the surfactant that is coating these surface water molecules, the surfactant is going to cause decreased air-water interface. And as a result of that, there is going to be decreased surface tension. And so that's one of the really high yield things that you need to know about surfactant, is that it decreases surface tension. And we just said that surface tension is a collapsing force. Surfactant, therefore, decreases the tendency for alveoli to collapse. Now, just as an aside here, I illustrated in the diagram that there are these tiny gaps between the surfactant, and so it's not eliminating all air-water interface, it's just decreasing air-water interface. And actually, during inspiration, there are more gaps, and so there is more surface tension, whereas during expiration, there is less gaps between the surfactant molecules, and so there is going to be less surface tension. And as a result of more surface tension during inspiration, it's harder to hold the lungs open at any one position during inspiration than it is to hold the lungs open at any one position during expiration. And this difference between collapsing pressures between inspiration and expiration is called hysteresis. And you don't really need to know why there's larger gaps between surfactant molecules during inspiration versus expiration. It's just the way that surfactant is packed during inspiration and expiration. Just know that there's a difference in surface tension between inspiration and expiration, and that's referred to as hysteresis. All right, and just finishing up here, there is going to be two very high yield lung conditions that we're going to be speaking more about in pathology. One is called neonatal respiratory distress syndrome, and the other is called acute respiratory distress syndrome, and they're both characterized by a deficiency of surfactant. So if we have a deficiency of surfactant, that's going to lead to increased surface tension. And as a result of the increased surface tension, which is a collapsing pressure, the lungs are going to want to collapse. And I've seen in a boards question where they said there was a 2-day-old infant who was having a lot of respiratory distress and very low oxygen levels and then died. And then on autopsy of the lungs, they saw alveolar cuboidal cells that possessed decreased amounts of organelles that have layers of flattened membrane. And so the cuboidal alveolar cells they were referring to were the type 2 pneumocytes, and the organelles they were referring to were the lamellar bodies. And the question basically asked, what would be the consequence of having decreased lamellar bodies? Well, if we have decreased lamellar bodies, we're going to be storing less surfactant, which means we're also going to be secreting less surfactant. And if we have decreased surfactant, that means we're going to be having increased surface tension, and then we're going to have alveolar collapse. And that was the answer. It was increased tendency for the alveoli to collapse. All right, and that's all we got for our video on surfactant.